All right, today we're going to be looking about how to make imaginary roots real. So we're going to be seeing the connection between imaginary roots, which is something that we can't really see on a graph usually, and how we can actually convert that into a related parabola to actually see the related real roots. So here's our first task. We're going to graph and find the roots of f of x equals negative parentheses x minus 2 squared minus 3. So go ahead and stick in your little sticky graph I gave you in class. So what we do is we're going to graph it first. So since this is in vertex form, it tells us a lot of information already. So we know already that the vertex is going to be 2, negative 3. Okay. Since we have a negative value here, all right, that means our parabola is going to be facing downward. And remember our anatomy of a parabola, it usually goes over 1, up 1, over 2, up 4, over 3, up 9. So since this is negative, those all become negative values. So I'm going to go over 1, down 1 on both sides of my vertex. Over 2, down 4. I'm going to make my parabola then. So if you notice here, we know this is going to be imaginary or complex solutions because it never crosses the x-axis. So we know our discriminant is going to be negative. So we need to solve for it. And the only way we can solve for this is using our square roots. So I'm going to take my function, negative x minus 2 squared minus 3, and set it equal to 0 and use our algebra skills to solve. So I'm going to add 3 over, divide by negative 1. The square root of both sides. We're going to look at that radical. We're going to change that radical. We're going to change it so that the negative is no longer underneath. So we're going to say I radical 3. And then add the 2. So 2 plus or minus I radical 3. Okay, so here are our imaginary roots. Okay, and that makes sense of on the graph why it doesn't cross that x-axis because it's I that it can't. Now what we're going to do is we're going to shift this and we're going to actually see how we can make those imaginary roots of 2 plus or minus I radical 3 actually appear on our graph. So what we're going to do is we're going to write a related parabola. And what a related parabola means, it's going to have the same vertex. It's going to have the same vertical stretch. Remember, our vertical stretch was just 1 here. It's just going to be flipped. So we're going to reflect it over that axis. All right, so if I'm looking at this, my original parabola was this. So if I just reflect it over, instead of being a negative, it's going to be positive now. So my new parabola is going to be x minus 2 squared minus 3. So let's graph that and see what happens. So now I have my vertex. I'm going to go over 1, up 1, over 2, up 4. So now we see our vertex kind of coming alive here and our parabola coming alive because now we can see we have x-intercepts. So we can figure out what those real roots are going to be. So let's go ahead and solve for those real roots. So set it equal to 0. I'm going to add 3. Square root both sides. All right, radical 3 is okay. We don't have to change that at all. I'm going to add the 2. And there's my solution, 2 plus or minus radical 3. And these would be our real roots. So there's no imaginary numbers. Now look at those two solutions there, guys. They're the exact same. The only difference is one has an I. So if you want to, you can take any problem that has imaginary roots and actually see graphically